Hi Math Cats. I hope you've been successful at learning how to solve equations with one unknown, with an x. Usually it's an x that's in your problems, because when the algebra was first developed and they started making books about it, the mathematicians said you can use any letter you want in these equations. And the printers went and looked at their bins of letters. You know, every book had to be typeset one letter at a time. They saw that they had lots of x's left over, so they just had a favoritism for putting x's in equations. And now you kids get nervous if we use another letter, but x is sort of the traditional unknown letter. What we're going to start on next is what happens if instead of having just the one unknown, like the unknown x, we introduce a second unknown, like a y. How do you go about solving an equation with more than one unknown? That raises the question, how many unknowns can you have? Long time ago now, probably before you were born, I took a job in the summer. It was for teachers to work at one of our national labs. Somebody had the idea that we teachers should work in the real world and know what the real scientists do. And I thought that was a very good idea. I worked in the physics department at one of the national labs, and I was dealing with climate modeling, and I had an opportunity to meet scientists working on robotics and nuclear, various things that were always interesting to me. But as a teacher, I used to have some questions I would ask them, and I'd say, on a daily basis, how many unknowns do you deal with? And I was surprised to see that many of them said, something like 20. And I hate to tell you this, but if you have 20 unknowns, A, B, C, D, that's a lot of them. If you have 20 unknowns, you need 20 equations to work together in order to solve them, or you need 20 pieces of information in order to find a unique solution. Now, we're not going to torture you with 20 unknowns in high school, but we are going to torture you with 2, maybe 3 unknowns. And once you get the principle that's being used here, then you can go on to use more electronic means and things to find the solutions if you have more unknowns. Now, one thing you have to make sure that you understand eventually, at first we'll let you just sort of slide through, is that you have to understand that if you have 2 unknowns, you need 2 unique pieces of information about it. Just like when you have 1 unknown, you have to have 1 equation with unique information about it. And we've already seen that sometimes it looks like you're being given information, but you're not. Like if somebody said x plus 5 equals x plus 5. That's an identity. It doesn't have a unique solution. And if somebody tells you a lie, like 2x plus 5 equals 2x plus 6, that's contradictory and there's no solution. Well, you're going to have the same thing with 2 unknowns. You have to make sure that the information given you in 2 equations is unique and is not what we call dependent. And then, if you have such information given to you in equations, you can solve for a single solution for a system of 2 equations in 2 unknowns. Likewise, if you have 3 independent equations in 3 unknowns, you can solve for a unique solution for that system. Now, of course, we're just talking about variables raised to the first power. Higher powers are yet to come. More fun in math. But right now we want to concentrate on equations in the first degree where the powers on the letters are the first power, and there are 2 unknowns. There are several methods we have for solving these, and I'm going to make a number of videos to show you those different systems. I hope you'll stay with us and conquer algebra. Thanks. Bye.